In the last class, we have seen what do you mean by consistency and how do you check the consistency for the system of linear equations. If it is consistent, whether it has unique solution or many solutions. For these things, we have seen some conditions in table form. Now we can find the solution for this system of equation given in the exercise 1.6. First problem, first submission, page number 42 in our material 62. The question is test for the consistency and if possible solve the system of equations by rank method. This is the question given. Now these are the three equations given. Whenever you want to check the consistency, test for consistency means first of all you have to check the rank of A and the rank of AB. AB means augmented matrix. Therefore first we can find the augmented matrix. The augmented matrix is, just you can write A, B, which is equal to, so you first write 1, minus 1, 2, 2, first row. Then second row, 2, 1, 4, 7. Third row, 4, minus 1, 1, 4. Now this is the augmented matrix. Now if you need, you can draw this line, otherwise you can leave it. Now after this you have to bring this augmented matrix into row echelon form. For that, as usual, the first element is 1. Therefore you have to consider these two elements. You have to make them as 0 with the help of the first row. Therefore now we are going to write the first row as it is. That is 1, minus 1, 2, 2. Now second row I want to make 0 means, if this is 2 means this also must be 2. Therefore you can write a new R2 gives R2 minus 2 times R1 because they have same sign. Similarly for R3 we can write R3 minus 4 times R1 because this is 4 means this must be 4 and they have same sign, therefore you are subtracting. Therefore first you have to take a rough work, you can do it, or else you can multiply this by 2. That is 2, this is minus 2, this is 4, this is 4. Then you try to subtract. 2 minus 2 gives 0. 1 plus 2 gives 3. 4 minus 4 gives 0. Then 7 minus 4 gives 3. Then after that we can do this next row. See here. You have to multiply by 4, you can write 4, this is minus 4, 8 and this also 8. Then subtract 4 minus 4 gives 0, minus 1 plus 4 gives 3, then 1 minus 8 gives minus 7, then 4 minus 8 gives minus 4, minus 4. So, we made these two elements as 0. Next in the second row, this is first non-zero element. Below this we have to make this element as 0. Therefore you can keep the first two rows as it is. You can write first two rows as it is. The first row 1, minus 1, 2, 2. Then second row 0, 3, 0, 3. Now next we want to make third row 0 means that is R3 gives R3. See, you want to make this 0 means you have to use its only previous row, not the first row. Therefore these are equal means that we can subtract R3 minus R2 we can write. That is 0 minus 0 gives 0. Then 3 minus 3 gives 0. Then minus 7 minus 0 gives minus 7. Then minus 4 minus 3 gives minus 7. Now we got it. Now this is in row echelon form. See here. Here under this first non-zero element we have all zeros. Similarly the second row, this is the first non-zero element. Below this we have 0. Now you need not bother this 0 and all. First you have to consider only first non-zero element. Okay. Now it is in echelon form. After that this is the matrix AB. Now here we know very well. This is equivalent to augmented matrix AB means this first matrix, this one is nothing but equivalent to A, equivalent to A. Now this is fully, you can consider as a augmented matrix AB. The first 3 rows and 3 columns nothing but equivalent to A. Therefore, at this stage itself, we can find out both rank of A and rank of AB. Here, rank of A is, see here, this is A. In this A, if A is in row echelon form, definitely AB is also in. If AB is echelon form, we can say A is also in echelon form. Therefore, listen here, this is in echelon form. Here we have 3 non-zero rows. Therefore, rank of A equal to 3. And rank of AB is equal to, here also we have 3 non-zero rows equal to 3. And here n is equal to number of variables. Here x, y, z, 3 variables, n equal to 3. Now, therefore, by Cauchy-Capri theorem, we can say rank of A is equal to rank of AB is equal to n, equal to n, or you can say equal to 3. We think they can write a number of unknowns, number of unknowns, number of unknowns. Therefore, if rank of A and rank of AB both are equal, definitely the system is consistent. And after that, you have to check whether it has unique solution or many solution. See, this equal to 3, this equal to number of unknowns, means if all these 3 are equal, definitely the system has unique solution. How do you find the unique solution? After this step, you can write as all are equal, means you can say the system is consistent and has unique solution. If rank of A equal to rank of AB equal to 3, that is number of unknowns, n value, means we can say the system is consistent and has unique solution. Then let us see how to find the solution again. See, from this equation number 1, we can write the equation. This is variable x, y, z and a constant. Therefore, we can write x minus y plus 2z is equal to 2. The next one, 0x plus 3y equal to 3. The next one is minus 7z is equal to minus 7. Here this is equation number 2, this is equation number 3. Now, from this last step, we can write z is equal to 1. We can write z is equal to 1. Then, after finding z equal to 1, we can go for the equation number 3. That is, equation number 3 implies, here also a single variable, therefore we can say y is equal to 1. Then after that, you can go for equation number 2. Equation number 2 implies, see here, x minus y means minus 1 plus 2z means 2 into 1, 2, which gives 2. Now you can say from this, you can say x is equal to 1. X equal to 1. Therefore, the solution is, x is equal to 1, y is equal to 1 and z is equal to 1. Therefore, we can say the system has unique solution. That's all. Likewise, you can do the next solution. Second solution of the first problem in the page number 42 of the exercise 1.6. In our material is problem 62, second solution. Now, here also the same thing. I have to check the consistency for the system of equations and if possible, you solve them by rank method. Therefore, whenever you are asked to find out, to check the consistency, it is better to go for finding rank of A and rank of AB. Therefore, first we can write the augmented matrix. The augmented matrix is, we can write A, B. See, you can write like this also. You not put slash, just you can leave space and you can write nothing wrong. Now, it is equal to, now we can write the first one, 3, 1, 1, 2. The second one, 1, minus 3, 2, 1. Third one, 7 minus 1, 4, 5. Now, if it is augmented matrix, it's better to put like this, nothing wrong. Okay, now, if you want to make this first element as 1 means here, all the elements are not divisible by 3, therefore, you can get 1 here, therefore, it is better to interchange R1 and R2. We are interchanging R1 and R2. R1, we are interchanging with R2. Therefore, can write 1 minus 3, 2, 1. Then 3, 1, 1, 2. Then you can write 7 minus 1, 4, 5. Now, after this, under the first element, you have to make these two elements 0. Therefore, you can keep the first row as it is, 1 minus 3, 2, 1. Second row, you can write as both are same sign, therefore you have to subtract. If this is 3 means this also multiplied by 3. Therefore, you can write R2 minus 3 times R1. R2 minus 3 times R1. Here, let me do a rough work. 3, the second row means 3, then 1, 1, 2. Now, this is to multiply 3. That is, you can write 3 minus 9, then 6, then 3. Then after that, you try to subtract. We are subtracting. 3 minus 3 gives 0. 1 plus 9 gives 10. 1 minus 6 gives minus 5. Then 2 minus 3 gives minus 1. Then we can go for R3. R3 means R3 minus 7 times R1. R3 minus 7 times R1. This R3 means 7 minus 1, 4, 5. Then 7 times R is 7. Then minus 21. Then 14. Then 7. Then if you subtract 7 minus 7 gives 0. Minus 1 plus 21 means plus 20. Then 4 minus 14 means minus 10. Then 5 minus 7 means minus 2. Minus 2 you can say. Okay. After this, see here, under this first non-zero we have 0, therefore I have to make this as 0 with the help of its previous row. Therefore you can write here equivalent to first row and second we can write as such 1 minus 3, 2, 1. The second row 0, 10, minus 5, minus 1. Then here, want to make this 0 means R3 gives R3, both are same sign means minus 2 times R2. You can write 2 times R2 because this is 20 means this must be 20. Therefore, first you can write 0, then 20, minus 10, minus 2. Then this is to be multiplied by 2. That is 0, then 20, then minus 10, then here minus 2. Then if you subtract 0 minus 0 gives 0, 20 minus 20 0, minus 10 plus 10 gives 0, then minus 2 plus 2 gives 0. Now here this is the augmented matrix AB. Now this last echelon form, the last equivalent matrix is in echelon form, that is under the first non-zero element you have zeros, in the second one is the first non-zero element, below this you have 0, therefore you need not bother about these things. Now it is in echelon form. Now if it is in echelon form, then we can say the rank of A and AB. Rank of A means the first 3 columns I told these 3 makes rank of A. See, rank of A means we have 2 non-zero rows, therefore we can take rank of A equal to 2. Then rank of AB. Rank of AB means we can say here also in AB also you have only 2 non-zeros, you can get 2. Now here after that you have to find the number of variables. Number of variables means x, y, z, 3 variables equal to 3. Now we can say by Cauchy-Shapley theorem, we can say rank of A equal to rank of AB equal to 2. Equal to 2, which is less than number of unknowns, which is less than n. N equal to 3, which is less than, you can say. Therefore, if these two are equal, definitely the system is consistent. And the rank is less than n means we can say it has infinitely many solutions. If all three are equal, we can say consistent and has unique solution. If these two only equal but they are less than the value of number of variables, means we can say the system has infinitely many solutions. Therefore, we can say the system is consistent and has infinitely many solutions. Infinitely many solutions. Therefore, we can take this last echelon form as equation number 1. From this equation number 1, we can write the equations. Therefore, from equation number 1 implies, we can say this is x, y, z. We can say x minus 3y plus 2z is equal to 1. Then we can say 0x plus 10y minus 5z is equal to minus 1. The last one equal to 0 equal to 0. 0 equal to 0. As I told, if 0 equal to 0, LHS is equal to RHS means definitely the system will have infinitely many solutions. See here, if 0 equal to 0, this type of equations is called a trivial equation. This type of equation, 0 equal to 0 comes, we can say this is a trivial equation. Whereas these two equations are called non-trivial equations. These two are called a non-trivial equation. Therefore, you need not consider this one. You try to consider these two equations. Now, we have only two non-trivial equations. We have only two equations, but we have three variables. Already I told the number of equations must be equal to the number of variables, then we can easily solve. Therefore, if there are two equations, we must have only two variables, but we have three variables. Therefore, from the last, that is if x, y, z, three variables are there, first you assign the parametric value for the last variable set. Then you can assign for the variable y. Then you can easily find the value of x. If you go like this, you can easily find the solution. Therefore, here you can take this as equation number 2. This is equation number 3. Now we are going to assign the parameters. Here, three variables are there. Only two equations, means the difference between 3 and 2 is 1. Therefore, you have to assign one parameter. Hence, it is called one parameter family of equations. Therefore, that one parameter can be assigned for the last variable z. You can assign for y also, nothing wrong. But if you do like this, it's very easy to find. Therefore, we can define let z is equal to t. Z is equal to t, comma t belongs to or t is any real number. After defining z value, this value can be replaced in equation number 3 to get y value. Therefore, we can find a y value. See here? Therefore, equation number 3 implies, see, 10y minus 5z, z means t we have taken, t equal to minus 1. From this equation, we need to find the value of y. Therefore, you can say 10y is equal to 5t minus 1 minus 5t becomes plus 5t. Therefore, from this y is equal to 5t minus 1 by 10 you can say. 5t minus 1 by 10 you can say. This is y value. This is y value. Then after finding this y value, it is better to find the x value from this equation number 2. Therefore, equation number 2 implies x minus 3 times y. 3 into the y value is this one, 5t minus 1 by 10. Then plus 2z. Plus 2 into what is that value? Z equal to t, which is equal to 1 from this second equation. Okay. Now we have to find the x value means since here we have denominator 10, therefore you can multiply throughout by 10. Then you will be getting 10x minus 3 into 5t minus 1 plus 20t is equal to 10 we can say. Yes, after that try to remove the bracket. You can write 10x minus 15t then plus 3 plus 20t is equal to 10. Now after that you can write 10x equal to first we can take this one. This is 10. This 3 goes inside, minus 3 gives 7. Then minus 15t plus 20t gives plus 5t, goes that side minus 5t. Therefore, x is equal to, we can say 7 minus 5t by 10. This is x value. Now we found the values of x, y, z. After that we can write therefore the solution is x comma y comma z is equal to the value of x is 7 minus 5t by 10. Then the value of y is 5t minus 1 by 10. Then z value is t, already we have taken. Now this is the required solution. Here this t is the parameter we can say where t belongs to R. Where t belongs to R we can say. Yes. Now we have introduced only one parameter, hence this system is called one parameter family. Now for different values of t, you can get infinitely many solutions. For example, suppose if you put t equal to 0, the solution will be 7 by 10, comma 5, minus 1 by 10, comma 0. Suppose you put t equal to 1, you can get 7 minus 5, 2. 2 by 10 means 1 by 5. Here t equal to 1 means 5 minus 1, 4. 4 by 10 means 2 by 5. Then you can write 1. Like that you can find infinitely many solutions. For different values of t, we can get different solutions. Since t is a real number is what infinite set. Therefore, definitely we will have infinite number of solutions. Therefore, we can say this is the required solution. Likewise, you try to do these problems once again by seeing these things. The next problems we will see in the next class. Thank you, children.